This is lecture 20, example 1. And what we have here is, we've been talking about, well, switch bouncing in one shot. So this is going to be just a normal problem. As far as programming goes, we don't have to worry about switch bouncing in one shots because we're going to do that in hardware. And so let's do this. So essentially this is a program, an interrupt-driven program that every time it gets an interrupt, it's going to read from an input port, which is, I think I call them the switches. So it reads from the switches, and then it's going to output the switch value that it read 3 inputs ago, 3 interrupts ago. Okay, so this is a classic problem. I like using it because it's simple if you understand it, and it's not that really hard to understand. So every time it gets an interrupt, it's going to output the value that it read from the switches 3 interrupts ago. Okay, so that means that this is going to have storage element. It has to remember what it read a couple times ago, and that's the key to making this problem work, is that I'm going to use some registers as, we'll say, intermediate storage registers to make this work, and that's the key to making it work. So every time I get an interrupt, I'm going to shift those registers around. So it's kind of like a program that implements a shift register. So shifting values through registers. So could be done very easily in memory as well. I think I'd like to do this with register. I think it's more straightforward that way. So it is interrupt driven. So we'll crank through this. We'll try to be a good citizen here and make a decent flow chart. So I'll do it here. This is my program, and I just have to init a bunch of stuff. I'm going to say init ISR, then we're going to init non-ISR stuff. Okay, so then last thing I want to do here is enable the interrupts. And I'm not gonna, I'm gonna work off my cheat notes from one of the original programs on this. A lot of this stuff I just don't have it committed to memory. I could probably figure it out, but I have cheat notes sitting in front of me, and hey, cut and paste. That's the way to do it. That's the way everyone does it. Although I will write it from scratch in the example problem. Okay, so that gets me started here, and I'm going to use the flag approach again. So if the flag equals 0, I'm going to keep looking for an interrupt. So once again, it's one of those ugly poll things. And so after that point, if I do get an interrupt, I am going to, what am I going to do? Okay, so I'm going to, I don't know, I'm just going to say transfer. I'm going to transfer a bunch of stuff around, do some admin. Admin is very similar to before, and then go back to the end. And the interrupt service routine is just a matter of setting a flag. And returning. But the key here is when I get an interrupt, well, what am I going to do? So I agreed that it's going to be something where we have 3 registers sitting there, and I'm arbitrarily call these x20, x21, x22. And so what's going to happen is I'm going to get an interrupt. Don't do that. I'm going to put my value, load a value into this register, and then I am going to output the value from this register. So this will be load, and this will be store. And once I do that, what I'm going to do is take this value and copy it there, and then I'm going to take this value and copy it there. Okay, so then I've stored the last 2 values. They're ready. It's ready for the next interrupt. So once again, I get an interrupt. I'm going to write a value here. I'm going to output this value, and then before I leave, I'm going to transfer this value here and that value there and get ready for the next interrupt. And I think we essentially got to memorize this. I don't want to draw the picture and move it over there. Maybe I should. Let's grab the picture. Okay, so there's our flow charts. I will grab this picture, get it set up to do the programming on the other side. And I'm going to pull up RARs on this one because it's interrupt driven. Okay. Okay, so here we are in programming land. Hopefully you can see this. I copied this, and I'm actually going to work off this. And I actually have my cheat sheet of the original code up here for interrupt driven programs. So I'm gonna have to work off that. So we're gonna call it I don't know, main's not a really good word for it. Call it program. Probably not a good word anyway. Init, and then I need to init some stuff, and the stuff I need to init in this one, I need to get those registers loaded. So I'll say x15, and this is the two addresses in the problem, which are 0x11008000. This is something. Switches, and next thing I'm going to put these in a register also. X16 0x1100C000. I think this matches the wrapper anyway. LED, so that looks good. And ready to. I'm actually doing this box right here. Init this box, init non-ISR stuff. So as far as the ISR goes, I need to write the interrupt vector, and that's going to be a load address of my ISR, which I'm going to load into. I don't know. I always say X6 because it. I think the GCC compiler uses that. Load address, and we'll make this happy here. So we don't forget, we'll put an ISR down at the bottom here. Okay, and this is going to be my store CSRRW. I already ran out of room there. I like keeping it perfect. CSRRW, there's my little hints up there, but this is going to be X0 because I'm not using it, and MT vec. And the assembler knows about that, and so what I'm going to do is put that vector address there, and we'll skip a comment for that one. Okay, so what else do I need to do here is I have a flag variable, and I'm just going to use the flag variable as X8. Move a 0 in there. What else am I going to do? I always I guess we're almost ready. What next thing I need to do is turn the interrupts on. That's pretty much the last thing I do in the initialization sequence. And so this is going to be, looking at my cheat notes here, this is going to be just move, I got to write a 1 to that register. So I got to move a 1 into the register, and then I need to write it. And so I'm going to go ahead and copy this instruction just to save time. And this is IE, and it's X10. Okay, I don't know if that's saved any time or not, but this is enable interrupts, and this one is clear counter, and looking good. I'm going to do I think that I need to do something else, but I'm not going to worry about it right now. There's my loop. Okay, so looks like we did all this stuff, and now I'm here, and this is waiting for an interrupt. So this is going to be, I'm going to use X8, and so this is the BEQ X8 X0. So as long as X8 is equal to 0, I'm going to branch to loop. So that's going to be my polling loop, which you're not supposed to do, but we're doing it here because we have nothing better to do. So that's my polling loop. And so if that flag does get set, it's going to drop out of this thing. So I'm going to say we should come down here, the ISR, and write our ISR. ISR move x8. We need to move a 1 into it. It looks like we still have 1 in x10. So we'll use x10 to set that thing. Move, we'll say set x8. Okay, and then this end of this thing, MRT, put in a dumb comment, return home. Not that I know where home is, but, and I like making sure these are stand out. Okay, and there's my interrupt service routine. So that is x8. X8 is going to stuck here until I get an interrupt, which is 0. I'm sorry, get an interrupt, and then that means x8 is no longer 0, so it's going to break out of this polling loop here. So at that point, we've done interrupt service routine, we've done the yes, and I'm sorry, we has 2 yeses. Okay, this should be a no. I can maybe even fix that. Let's see if I can fix that. No. Oh, maybe I can. No, I'm just gonna skip it. This should be a no up here. My pen isn't working. So this is what I need to do right here, is implement this transfer subroutine. And what I need to do is first go get some data. So this is a load word, and it looks like we're going to put it in x20, 20, and the address is 0. It's the switches. So this is 0, x15, which is the switch data, and say get the switch data. Okay, at that point, I want to output this data. This is my oldest data, and so I'm going to output that thing. So I'm going to say switch blah blah, or sorry, not switch, store word, which is my output. This is x22, 0. The address is the LEDs, x16. That's the output address. Okay, okay, that's good. And now what I have to do is do these 2 arrows here. And so x20 has to go into x21. Move x, it's backwards, x20 into x21. We'll say transfer data. And I think I need to do that again. So I'll copy and paste. Oops. Okay, and I'll do that again. This is going to be x20 goes x20, x21 goes into x22. And I think I'm ready to go after that. That implements this whole transfer function. What I have to do is administration work here. The administration work is going to be re-enable interrupts and turn that flag off. So that's move x8, x0. That's going to clear the flag. And this is going to be, let's just cheat here. Since I already did that. Okay, enable interrupts. And then lastly, jump loop. Okay, and that jumps back to this loop, back to the polling loop. And I believe that's all we need to do. Maybe shorten this up a little bit. And yeah. So once again, and how does this look? Okay, so I'm thinking, I think the problem stated that the very first things I want to output should be 0. And so I think part of this initialization sequence, I need to move 0 into those registers. So let's see, x20, not x20, x21 gets x0, move x22, x0. Okay, 22. Yeah, that's all. Okay, so that's one. Let's just say clear registers. And the problem stated that the first two outputs needed to do this, and so if I didn't do this, it would just be outputting junk maybe. This ensures it's outputting zeros as the problem stated. And at that point, I think we're done. We'll see if it, we'll go over to execute here, if I can go over there. Oh, I'm sorry. Let's go ahead and save this thing. .junk.f, and it saves it somewhere, and then I'm ready to execute it. Let's assemble it, and it went over there, and life is good, and I'm going to say this is done. We'll come back first. Okay.